So here we've got a set of notes that's called From Standard Form to Factored Form. And we've been looking at polynomials in standard form. And remember, that's where we write them term by term with the biggest exponent first. But there is another way that we can write polynomials, and that's factored form. And when we write it in factored form, we're going to break it into pieces that multiply together to give us the same thing as what we had in standard form. So what we'll do here is, let's see, you know what? Try that one again. Let's just do this. What we've got here is some notes, and you should have this handout in front of you. It's called From Standard Form to Factored Form. We've been looking at polynomial functions in standard form for quite a little bit of time now. And remember, standard form looks like this, where we've got our polynomial set up term by term and ordered so that our biggest exponent is first. And that's what standard form looks like. Now, factored form is going to be where we have our polynomial broken up into pieces that multiply together. Just like with our quadratic, we had standard form and factored form. Same thing with the polynomial. We're going to be able to write it. Now, don't write this piece down. I'm just showing you as an example, right? We're going to be able to write it as binomials that are all multiplied together, x plus or minus a number here. That's what factored form is going to look like, and we want to learn how to do this, how to switch between standard form and factored form. So this is what we're going to do here. Okay, so this first one here says identify the degree, and remember the degree is biggest exponent, and we can see here that's a 3. So the degree for this polynomial is a 3. Okay. Next it says to write it out in factor form, we need factors. So let's check if we can find one. And just to give you another example, because we'll kind of come back to this, let's just do a simpler example. Let's say we had a number, right? Like a number 10, and we wanted to write it in factored form. Well, if we know a factor, say for example, 2. Is 2 a factor of 10? Yes, it is. Okay. If we divide 10 by 2, then what we get over here, 5, is another factor of 10, and we can write the 10 in factored form like this, 2 times 5. This is factored form because these pieces are multiplying together. Okay, so we're going to do the same thing here. We're going to look for a factor, and then we're going to divide. So it says down here, use synthetic division to show whether any of the following binomials are factors. The way we do this is we're going to do synthetic division, and if we get a remainder of 0, that means that we have a factor. So let's go ahead and try it with the first one. So we're going to divide this polynomial by x plus 1 using synthetic division. And remember, the way that we know if it's a factor is if the remainder is 0. So let's try this here. Set up synthetic division. Change the sign on this, so that's going to go -1. Line up our coefficients up top. So let's see, that's a 1, -5, -2, 24. Okay, and let's do it here. Bring down the 1. 1 times -1 is a -1. Let's add these together. -6. Again, multiply there and there. Negative times negative is a positive. Add these together, we get 4. 4 times -1, -4. And when we add these together, hey, look, we can see here, this is our remainder. It's not a 0. So that means it's not a factor. Okay. X plus 1 is not a factor. All right, let's check x plus 2. So we'll do the same thing here. Now, I can just use these exact same coefficients because we're using the same polynomial. This is the polynomial that we want to factor. Those numbers don't change. 1, -5, -2, 24. Here our k value is going to be a -2. All right, let's give this a try and see what we get. Bring down the 1, add these together, multiply there, we get a positive 14. -2 plus 14 is 12. 12 times -2 is a -24. Take a look here. 24 plus -24 is a 0. So here's our remainder, and it's a 0. So that means we found a factor. X plus 2 is a factor. All right. We found one. Okay, so let's go ahead and fill this in here. Now that we found a factor, we can move forward. Since x plus 2 was a factor of our polynomial, then we can rewrite it as a product of the divisor and the quotient. Okay, so what does that mean? Write it as the product of the divisor and the quotient. Well, let's just like do an example with the number. That's like if we had, say, the number 24 and that um, we found that 2 is a factor, right? So 2 is a divisor. We could write this is equal to 2 times 12. Okay, so that's what we're going to do here, but with our polynomial. We're going to write it as x plus 2 and times what? What's going to go here? Well, that answer is actually going to come from the synthetic division. Let's take a look at this. So when we divide it by x plus 2, we got a remainder 0, but this piece right here is going to give us the other factor, the rest of what we need here. So let's just make sure that we double check. Up here was a degree 3 polynomial. That's what we divided. So this was x to the power 3. Okay, and these counted down. Remember here that when we do synthetic division, at the bottom, it's 1 degree less. So this is going to be x to the power 2, right? This was a 3, drop it by 1, down here it's a 2. So x squared, x, and constant. So that means what we have here is x squared minus 7x plus 12. And that's what we're going to put here. X squared minus 7x plus 12. And these two things are actually equal. This polynomial is equal to this binomial times this trinomial. If you wanted to check it, you could plug it in on Desmos and check. All right, let's keep going here. Okay, here it says, notice how one of our factors is still not a binomial. That's this one here. This one is a trinomial. So that means we're not done. There's more to factor. So we're going to factor this trinomial. So let's write that down here. And hey, if you remember about factoring quadratics, this is what we've got here. We're going to write down our a, b, and c values, so just the coefficients. And then we can set this up in our bottoms up or diamond method. Put the a times c on top, so 1 times 12 is a 12. That goes on the top. put our b value on the bottom. And we need two numbers here that multiply to make a 12 and add to make a negative 7. Okay, well, here's the thing. If they multiply to make a positive, but they add to make a negative, the only way that's going to work is both of these numbers are negative. And let's see, factors of 12, you can check factors of 12 to see what pair adds up to a 7, and it's going to be 3 and 4. So this is what we got here. So that means we can write this quadratic in factored form, x minus 3, x minus 4. And so for step 4, piece it all together. Okay, so now we're going to write it in fully factored form. This was like if I went back to the example with the number, right, we had 24, and then we factored it into 2 times 12. But then if we realize, 12 can actually itself be factored into 3 times 4. And so we could write this as 2 times 3 times 4, 3 separate factors there. That's kind of what we're doing here, except, of course, it's not a number, it's a polynomial. So this is what it's going to look like. We have, let's see here. This binomial here, that's just going to come straight down, the x plus 2. And then this piece here, we just split it up into these two. So we're going to bring these two over here, x minus 3 and x minus 4. And now we've factored our polynomial into 3 binomials. Okay, so on number 4 here, piece it all together. So standard form to factored form. And here we're going to be able to write it as 3 factors. If we were to do this with the number, it's like, say, for example, we got the number 30, and then we figured out that we could factor it like this, 2 times 15. But then we realized, hey, we can also factor 15 into 3 times 5. So we end up writing it as 2 times 3 times 5, factored into 3 factors. We're going to do the same thing, except with our polynomial here. And we've already figured out what those 3 factors are. So let's bring those down here. The first one, x plus 2. Let's bring that down. And then the other two are right here, x minus 3 and x minus 4. Bring those over here. These are going to be our 3 factors. Okay, how many factors do we have? Oh, we already answered that, right? Look, each of these binomials is a factor. We've got 3 of them. So we've got 3 factors. Okay, part B. Are there any similarities between the two forms? Standard form, factored form. Do you notice any similarities? And I noticed some similarities, but I'm not going to fill any in here. I'm just going to leave that open for you. If you notice anything there, go ahead and write that down. What similarities do you notice? Okay, and then part C here, use Desmos to sketch the graph of f of x. All right, let's take a look at Desmos. And we'll type in our original function x cubed minus 5x squared minus 2x plus 24. There's the graph. Okay, there it is. We go ahead and sketch that. But let's also do this, since we've got Desmos open and we also have the same function in factored form. This is a way that we can actually check our work using Desmos. So let's type in here on the next line the factored form. X plus 2, x minus 3, and x minus 4. Now let's take a look at the graph. How many graphs do you see? I only see one there. And you know what? That's a good sign. That's a good sign. Look, if I turn off the red one, you see, look, there's the black graph, which is the standard form. And then if I turn the red one back on, the factored form, it lays exactly on top of the standard form. What that means here is these two graphs are identical, which means the two functions are identical, which is what we should have. We're basically saying over here that these are the same thing. This is just standard form, this is factored form, but they give us the exact same thing. And we can see on Desmos that that's what we've got, the exact same graph. Okay, so that's good. By the way, I'll just show you, if we got it wrong, it would look something like this. If I just change one number, maybe I'll change that 4 to a 5. Now you can see the black graph and the red graph, they're not the same. So that would be a wrong answer. But if we get identical graph, then we know we have the right answer. Okay, so look, let's sketch the graph. That's what it asks us to do. Let's get some key features. I think x-intercepts will be a good place to start. So we have x-intercepts at -2, +3, and +4. -2, +3, +4. And let's see, what about a y-intercept? Way up here. Let's see, where does this cross at? Crosses the y-axis at 0, 24. Oh, you know what? We can fit this on here. Let's see here. Here's 20, here's 30. Look, this means these are scaled by 2. This is 20, 22, 24, 26, 28, 30. So 24 is right there. Okay, and this graph is going down on the left and it's going up on the right. So let's just make a smooth curve that connects these together. Something like that. And there's our graph. Okay, next page here. What if we have a function with degree higher than 3? Well, let's take a look. Here we do. We've got a degree 4. So let's write that down. Degree 4. Use synthetic division to show whether any of the following binomials are factors. All right, let's check and see if we have a factor. We're going to do synthetic division and see if we get remainder 0. And here we got a remainder 0, which means x minus 1 is a factor. Okay, let's write that down here. X minus 1 was a factor. So we can write this down, right? Our original degree 4 function is equal to x minus 1 times what? Well, remember here, we're going to get that from these coefficients. So let's see, this was originally degree 4 up here, which means it's a degree 3 down here. So that's degree 3, degree 2. That's an x to the power 1 term and a constant term. That's going to give us this. Okay, now we want to factor this all the way. And again, factoring a polynomial all the way means you have nothing but binomial factors. And here, this piece here, definitely not a binomial. This is a degree 3. So we have to keep factoring. Now we're going to focus on this and see if we can factor it. Now, this is a degree 3. It's not a quadratic, so we can't do bottoms up method. Really, all we can do is try again. See if there's another factor that we can factor out using synthetic division. Okay, and over here, this is just kind of a note for you here. The goal of synthetic division is to reduce a polynomial until we get a quadratic, which is a degree 2. And then once we have a quadratic, then we can check and see if our bottoms up method or our diamond method will work to factor that. Okay, so we're going to check some more here. We're going to check using synthetic division and using this guy. So let's go ahead and try this. Synthetic division, let's see. Is x minus 1 a factor? And it was already a factor once. It's possible it's a factor again of this guy. We won't know until we try it. Let's see. Okay, so x minus 1, not a factor. X minus 2, not a factor. X minus 3, we got a remainder of 0. That means it's a factor. Okay, so our equivalent polynomial at this point is going to be, we've got x minus 1 from there as a factor. And then we've got x minus 3, which we just found is also a factor. And then what's left over here is going to come from right here. And let's see, up here, look, this 2 is the coefficient here. It's an x cubed term. So this was 2x cubed. Down here, the degree drops by 1. So this is x squared. This is x. This is our constant. So now we've got this quadratic here as our third factor here. 2x squared plus 13x plus 15. And so now that we have a quadratic here, we can factor the quadratic with our bottoms up method. And after we do that, then we'll have our function completely factored. So let's see, this is the piece that we want to factor, this guy, which is 2x squared plus 13x plus 15. Let's write down our a, b, and c values. And let's go ahead On the top, we'll do A times C. So 2 times 15 is a 30. On the bottom is our B value, which is 13. And then once we find the two numbers to make this work, we're going to divide them by A. So we're going to divide by 2 here and here. So let's see, two numbers that multiply to make a 30 and add up to make a 13. If you're not quite sure, you can take a look at the factors of 30. But this is going to be 3 and 10. And then important step here, if you can simplify, we need to simplify. Okay, 3 over 2 can't be simplified, so we're going to keep it like that. 10 over 2 certainly can be simplified. 10 divided by 2 is a 5. There it is. These are the two values that we're going to use. So x plus 3 over 2 and x plus 5 is how this guy factors. And then the last step in the bottoms up method is, of course, to take this number on the bottom of the fraction, bring it up, make it a coefficient in front of the x. So this is what we've got here, 2x plus 3 times x plus 5. Okay, and now we're going to put it all together. So now we're going to have our final factored form, our original fourth degree polynomial, fully factored. These are the pieces that we're going to use here. This binomial and this binomial and these two binomials. So let's put those all together. X minus 1, x minus 3, 2x plus 3, x plus 5. Okay, there it is. Now, I'm not going to check this on Desmos, but if you wanted to, you could check on Desmos, check that one with the original. Should be identical graphs. All right, so on the next page here, here's some notes to fill in this box. Here's a flow chart for factoring polynomials. What do you need to know? Well, it says here, and this is what you're going to fill in, you need at least one factor that divides the polynomial to reduce its degree into something factorable. You need at least one factor that divides the polynomial to reduce its degree into something factorable. Okay, what could prevent us from factoring completely? Well, if we're not able to find a factor, that would prevent us from factoring completely. Not being able to find a factor, right? Like, for example, when you try these problems here for check your understanding, you're given some choices of factors to check, and then you're going to check those. And for these problems down here, some of these should work. But what happens if they don't work? What happens if you're not given any factors to check? Well, and pretty soon we're going to learn a method to where we can identify potential factors. But for right now, you'll be given factors to check. Okay, and then here's the process. So you're going to start by using synthetic division. And remember, you need to get a remainder 0. That means you found a factor. If your remainder is not 0, you got to check something else. Once you do find a remainder 0, that means you found a factor, so that binomial is a factor. And then the quotient, that's the piece that's left over at the bottom of synthetic division. That's the other factor, the binomial times that piece at the bottom. If the quotient is a quadratic, then you can factor the quadratic using the methods that we've learned, namely bottoms up method. Okay, if the quotient is not a quadratic, maybe it's a degree 3, then you know what you're going to have to do is repeat this process using synthetic division. So you're going to have to do synthetic division again until you're left over with the quadratic. And then once you have a quadratic, you can factor the quadratic. And once you have your polynomial in final factored form, it's going to be all binomials. Just like this one up here, they're all binomials. That's what it's always going to look like, all binomials. Okay, check your understanding. Look, there's some problems for you to try here. I'm not going to do these for you. I'm going to let you try these. Maybe later on I'll show you some solutions if you are interested. But I want you to go ahead and give these a try. And of course, as you do those, use these notes up above as a reference. That's what we have these notes for. All right, and as always, if you have any questions with any of this stuff, let your teacher know when you see us in class. All right, thank you.